Everyone, welcome back to this new chapter. This is again one of the fundamental chapters where we'll be making a small application, ticket transition application. First, we'll design it, we'll code it, then we'll see what state design pattern is. We'll try to remove the flaws that we found in the code previously using the state design pattern that we'll learn. So this is going to be a fundamental chapter, and if you are very much familiar with state design pattern, you can skip this. So let's see what the question is. Okay, basically this is a ticket transition application, just like Jira. If you see in Jira, what you can do is a user can create a ticket, and basically there are states in Jira. If you see, there's a to-do state, there's an analysis state, progress state, done state, right? So basically a user can create a ticket here and a user can change the state of the ticket, right? So what we want to do in this question is we want to send a different notification whenever there's a state change. So for every state change, let's say the ticket went from analysis to progress, we want to send a notification saying that, okay, ticket went from analysis to progress. Suppose a ticket went from progress to done, we want to send a different type of notification, or let's say two notifications saying that, okay, ticket is done and you can move on to the next task. Let's say if the ticket comes from done back into analysis state, which means it's a critical task, right? And you want to send SMS notification and email notification. So basically we have different types of notifying or different tasks to do on every different state transition. This is what the question says. So we have to make this ticket transition application wherein if a state moves from state A to state B, there's a different sort of task that happens. So like we always do, let's move to the use case diagram. So now, if we have understood the question properly, we have one actor, which is user. Now, what a user can do is user can create a ticket. The other thing what a user can do is change the state of the ticket. Using this, let's move to the class diagram. If we have to talk about the basic entities, one would be user, of course, and another would be ticket, right? So let's go and first design user. So we can keep user simple. Let's just keep name in it. Next thing would be ticket. So ticket would have a description. Let's say string description. Okay. It can have all the different metadata which you can add. Okay. So we are skipping this. It can have a title also, whatever. Ticket is always created by a user, right? So let's have user created by. The next thing is ticket will always be in a certain state. It would be, let's say, in analysis state, then it would be in progress state, done state, whatever. So it will always be in a state. So let's have a enum then saying ticket state. So ticket state. So let's keep it simple for now. Let's have just three states. It could be analysis, review, done. Ticket will always have a ticket state. So ticket state, ticket state. This should be the class diagram. Of course, what all functions can a user do? So a user is able to create a ticket and transition a ticket from state A to state B. So I think we should have a ticket service also, which will help us do both these functions. Ticket service. So one is create ticket. So the arguments can be description, user who is creating it. I think that should be it. State, I think when a ticket is being created, it will always be in an initial state, let's say in the analysis state. Okay. So it will always be in a particular state. So string description and other would be user. What would be the return type? Return type would be a ticket. So ticket. So user was able to transition a ticket. So of course, transitioning of a ticket, this logic should also be handled by ticket service only. So change ticket state. This can be the function name. And what will we get? Whose state will we have to change? Ticket, right? So we'll get a ticket. And the other thing would be, what would be the new state do you want to transition it into? Ticket state, new state. What could be the return type? I think void would also do, boolean would also do, right? Depending on what the requirement is. So if front end wants to show some sort of error message, we can return a boolean. Otherwise void would also do. Right now the main focus of this question is on ticket transitioning and want to see the logic behind it. So for now we are keeping it void. I think these should be the two things that a ticket service would do. Of course, different questions can come to your head that, okay, user should be authenticated also, there should be assignee to the ticket also. We can have all that metadata and we can work around all of that. But right now, this is just a fundamental chapter on which we want to focus on transitioning, and later we want to understand what state design pattern is. So we are not going into that much depth, but Jira would be a full-fledged chapter that would be taken by us, where we'll be covering most of the functionalities. Okay, let's move to the code now. Okay, let's have DTOs inside it. So one more package DTO. We will also have an enum ticket, right? Ticket state. So let's have a package for enums also. And of course, we are also having one service. Let's make a package for service also. Okay, so inside DTO, let's first make basic user class and the ticket class. I think we should first make enum because enum would be used in the ticket, so which will give an error. So let's first create an enum ticket state. Right now we were only having 3 enum states, so analysis, review, done, good to go. Let's have now user and ticket class. Okay, let's first create the user. So let's keep a name in the user. Okay, let's just have a basic constructor for it. Okay, I think we are pretty much done with the user. Let's go and have ticket now. So we'll have description. So let's say description. Then who created this ticket? So user created by, and third one was state. So private ticket state, ticket state. Okay. So let's go ahead and make a constructor first. So like we discussed, what will we get in the constructor? The description we'll get. And of course, who created this ticket? So we'll get the user. Which state would ticket be in whenever it is constructed? So let's say it's an analysis state by default when a ticket is created. Okay. And we can have ticket state equals ticket state dot analysis. Okay, good to go. Let's just have getters and setters for all of these three. Generate getter setter. Okay, I think good to go. So let's create our ticket service. So ticket service. So the first function was creating a ticket. So public ticket create ticket. What were we getting? We were getting description. So string description. And the other thing was user who created it. So user created by. Okay. So let's create a ticket. So return new ticket. Okay. Description and created by. Let's now move to the main function transition ticket. Okay. So public void change ticket state, right? So what were we getting? We were getting a ticket first and the new state. So ticket state, new state. Okay, so like we said, we will have a different sort of mechanism for each of the different transition, right? This was mentioned in the question. Let's first fetch the old state and then we'll see how we implement different notification for different transition. Analysis to done, done to analysis, analysis to progress, progress to done, progress to back in analysis. So let's first fetch the old state. So ticket state, old state equals ticket dot get ticket state. So what were the ticket states that we were having? Okay, analysis, review, and done. Not progress, review and done. So we can have a if else if block here. Basically, if my old state is analysis and then my new state is review, so then we can print a message. Else, if my old state is analysis and my new state is done, then we can print something else, or basically whatever the user want to do. Right now we can log just to see the flow. If my old state dot equals ticket state dot analysis, then what? Now also we have two choices that if my new state is review or done. So if new state dot equals ticket state dot review. So right now I think we should just print. Otherwise you can log everything into a file also. You can keep the logs inside the ticket also. Just to keep it simple here, we are just printing the logs. System dot out dot println ticket dot get description moved from old state to new state. Basically, what you can also do is you can get the user also who is making the transition, and then you can have user in the here in the arguments, and then maybe you can keep it in the logs again that okay, this user transitioned or changed the ticket from this to this, right? Whatever you want to print. Right now the main focus is on building. What could be the other case? If my old state is analysis and my new state is done, so let's just quickly write that also. If my new state dot equals ticket state dot done, probably here in the old state we can have proper words, right? From analysis to review. Okay, here we can have a new state. Congratulations. For analysis, both the states transitions are covered. Let's make it quickly for review and done also. Else if old state dot equals ticket state dot review, then we have to do the same if else if block. So let's just copy it for now and we'll change the messaging here. So one of the state would be analysis. Okay, analysis, and other would be done. Let's print a different message from review to analysis. Pull up your socks. Okay, let's keep the same message for done. Okay, if there's a request saying move the ticket from analysis to analysis, then also we should also cover that case, right? So we can have else if new state dot equals ticket state dot analysis, then probably we can print an error message or we can throw an exception. Right now we are printing an error message. What are you doing? Okay, something of this sort, right? Okay. Same ways we can have it for review also, right? Okay. Review. And our last state, old state, could be done. So else if old state dot equals ticket state dot done, then we need to do the same three things. We have to implement the same three transitions. Okay, of course the messages would be different. So move from done to analysis. What's happening if a ticket is moved from done to back into analysis? Maybe you want to send SMS notification to major stakeholders, so whatever you want to do, you can have it here, right? If it's in done, maybe we can print is already in done state. And the last thing would be, again, we can have the same thing from analysis to review back again. Great. I think we're pretty much done with the change ticket state. Let's make a ticket and let's see the worker. How is it working? So let's first create a user. So user u1 equals new user, it wants a name. So let's say A. Now let's create a ticket. So ticket equals new ticket. What does it want? It wants a description, first ticket, and of course it wants a user. So let's say u1, right? Now what do we want to do? We want to play around with changing the state. So let's say we also will want to have an instance of ticket service also. So ticket service equals new ticket service. Okay, let's change the state of ticket. Okay, so what do we have to do? Tickets, we have to call ticket service dot change ticket state. Whose state do we want to change? So we want to change ticket. And what can be the new state? Let's say we want to move it to review. So let's say user u1 only is making a transition. Okay, so let's see what should be printed. Ideally, what should be printed is that okay, ticket moved from analysis to review, of course with some description. So first ticket, which is the description which we wanted to print. So if you see ticket service, it came to analysis and we wanted to shift it to review. So ticket description was first ticket, then we have moved from analysis to review. Okay, once again let's change the ticket state. Okay, and let's say we want to change it back to analysis. Okay, now let's print. Okay, so what are you doing? Because this was the message that we wanted to print. So I think we are pretty much done with the code. Everything is working fine. So what are the flaws which you can see in this piece of code? So if you see, there are complex conditional statements, right? So if tomorrow another state comes in, this will be getting much more complex, right? Which is of course not manageable. This looks really, really bad, and it is very hard to read it also. So of course you can think of doing a little bit of optimization here and there, but that would not be worth it because let's say when a ticket moved from analysis to done. So every time when a ticket moves to done, you want to delete that ticket. So where will you put that logic? Okay, so from review, it moved to done. So here you'll have to put the logic of deleting the ticket, right? Same way you'll put that logic here also when it moved from analysis to done, right? Along with maybe notifying stakeholders by different means, let's say sending SMS notification, email notification, whatever way. Okay, so every state transition has been handled in a different way, and this logic would keep on getting more and more complex, and this would not be readable, of course. So this piece of code is really bad. This is not manageable. Second, if you see, we have duplicated the code at a lot of points. If a ticket is moved from analysis to analysis, we are printing this message. What are you doing? Same ways, if old state and new state are same, basically you can see we are printing the same message. So don't you see code duplication at three different places, which we can avoid? So code duplication would be there, and there's inflexibility also. How? So if you want to add a new state, you'll have to change or revamp this complete piece of code. So this is really inflexible. If we see, because of all these reasons, this is a really bad piece of code and we need to revamp it. What comes into picture now is a state design pattern. Now we'll learn what state design pattern is, and using that state design pattern, we'll re-implement this piece of code. So I hope you've understood till now. If you have any issues till now, please post it in the chat or the discussions panel below. We'll try to answer them ASAP. Thank you so much. Now let's see what state design pattern says. So in state design pattern, we are first going to implement a state interface, which will define all the actions that we are going to do. Then we'll define all the concrete states that will implement that state. Okay. So state, it is going to be an interface. And of course, now we are going to define all the actions. Actions are a ticket is moving from state A to analysis. Now that state could be any, right? That state could be analysis, review, done, any. But transition can be to analysis. Same ways, transition can be in review, and same ways transition can be in done. So let's have these three functions. So start analysis. What will we get? Of course, we'll get a ticket. If you want to pass the user, right? So you can pass the user also. So now what I feel is return type could be Boolean. Why? So let's say if it is Boolean, okay. So Boolean can return if it is possible or not. That's why let's have it Boolean. Same as the other action would be start review. So, and of course the same parameters like we have above. And we can have return type as Boolean again. Same ways would be mark done. And the same parameters. So this should be the interface state. Okay, so now what we do is we have concrete states that will implement it. This is the UML symbol for implementing, right? So the first state is analysis, other one is review, and the last one is done. And of course, since all of them are going to implement it, so all three states are going to implement these three functions differently, right? Which enhances single responsibility principle. So now if we look at the class diagram fully, we had this user. Oh, sorry, we forgot to make relations here. So a ticket is going to have a user, right? So what is the relation between a ticket and a user? Can a user exist if ticket dies? Yes. So there is aggregation, not composition. This should be the relation between ticket and a user previously. Since ticket has a state, what change will we have? So instead of this ticket state, we'll have new state. This is the new change, which would be this interface state. Okay. What change will we have to make in the ticket service? So suppose you are the user, you moved the ticket from analysis to review. What will you do? You'll call ticket service and you'll ask him to move this ticket from previous state to review state. Now, previous state is of course stored in my ticket already. As you can see, previous state we just now said it is going to be stored already here, but now it is being moved to in review, in done, or in analysis. So my ticket service is going to implement all these three functions. So let's quickly write them down. Void start analysis. What will service do? Service will basically call the states function. And if we have to start analysis, what will we get? We'll get ticket and user. Same way as the other two functions like we have here. These two functions would be copied here. And we would be pretty much done with the class diagram then. You might not be getting little clarity over here, but trust me on this, when we'll code, you'll get much better clarity. And this is a fundamental topic where you are learning what state design pattern is. So please don't worry. Watch this till the end. Okay. So now let's go ahead and code it to the ticket. Before that, let's make a state. So let's make a new package, state. Inside state, we can have, of course, it is going to be an interface. Let's name it state only. Okay. Of course, we are going to have concrete classes, which are analysis, done, and review. So let's just quickly make them. Analysis. It is going to implement state. So, okay. Review implements state. And lastly, we are going to have done implements state. Great. So three functions which we had to make in here. So Boolean start analysis. What will we get? We'll get a ticket and the user who is making the change. Okay. The second one was start review and the same arguments. Mark done and the same arguments. So of course, we are going to see three problems because we haven't implemented the methods. Let's just quickly implement the methods. All three methods. Okay. So now if you see, when your state is already analysis and you're moving the state to start analysis, what will you do? Of course, ticket is already in analysis state. So we'll return false, but we can have a log here saying ticket already in analysis state. Okay, we can have this, or maybe let's open what we had. Let's put all the messages that we had ticket in the ticket service. Okay, so in the ticket service, if ticket had old state as analysis and we wanted, so let's print this message only. Okay, and we'll return false because state change is not possible from analysis to review. Okay, so when the state came from analysis to review, so let's just print this statement only. Okay, now you see we can return true. That okay, state change is possible. Whatever notifications you want to fire, you can fire. Okay, third one is marking as done. So if ticket is done, old state, let's just print analysis. Congratulations. Okay, and we can return true here. Same ways, let's quickly do it for review and done. Okay, so if ticket is in review and somebody wants to start analysis, what will we do? We'll just, is this transition possible? Yes, this transition is possible. If the ticket isn't already in review and somebody asks to start review, so let's just print this message, right? And we can return false because this transition is not possible. Third one, ticket is in review and we want it to be done. So let's just quickly, old state was review to done, congratulations, and we can return true. Okay, great. So review is also done, and let's make it for done. Okay. Let's do it for review. So I think we are pretty much done with the state transitions. So now if you see every state transition, whichever state it want to transition to, we have a separate function and they can be handled very easily. So you can see we are logging and this can be handled. So if you want to do something else also, you can clearly do right here. And this code is far more readable, manageable also. So yeah, so let's move to ticket service now and let's just implement all the same three functions that we have. These functions are telling whether the state transitions are possible or not, and they're maintaining the logs. Similarly, if somebody wants to send notifications or whatever, if they want to do anything, they can do it right here. Service is the place where any change to the ticket will happen. So public void start analysis will have a ticket user use. Okay. So what will we do? First, we'll check if this is feasible or not. So we want to call start analysis, right? So Boolean is feasible equals ticket dot get ticket state, because I want old state to transition to new state and I want to see if this change is feasible or not. So that's why getting the ticket state, and I want it to start. Okay, sorry, I didn't make the change to ticket. So let's just make a change. Okay, and we'll, okay, this is it. Okay, this is going to be state. We are done. So let's just quickly comment this out because it is showing few issues, because it will show issues. So yeah. Now what do we want to do? I've got the state, old state, and since I'm transitioning it to a new state, so what I'll do? And which state am I transitioning it to? Analysis, because it's start analysis. So which function will I call? I want to call start analysis function. So start analysis, what do I have to pass? I have to pass ticket and user, right? Now, what will I check? If this change is feasible or not. So if is feasible, then we can make the change. Ticket dot set ticket state as new analysis. Same ways, let's go for public void start review. Okay, we'll get the same things, ticket, ticket, and user. Same things we'll do. So let's just copy and paste quickly. What would be the change here? Now we have to call start review function, not start analysis, right? Start review. And if this is feasible, we'll change the state to review. Great. Let's do it for done also. Let's copy the same function. Mark done, done. And if it's possible, now if you want to delete the ticket also, you can delete it right here. So now if you see, we're pretty much done with what we wanted to do. And if you now see the piece of code, this is much more manageable, right? Now going forward, let's say one more state comes in. What do you have to do? You have to make one state here. If you want every other state transitions possible, so you'll have to make one more function here. Okay, let's say progress. So start progress, let's say, and each and every state will implement it. And whatever notifications you want to fire or whatever logs you want to make, or if you want to check if the state transition is possible or not, you can very well do this, right? I hope till now you have understood what state design pattern is. So if you have any doubts, I would recommend please watch this bit of video again and write this piece of code by looking at the screen again, and you'll get the clarity. So now if you see, what all problems did it solve? So it has first of all solved the problem of complex if else loops. So first problem is resolved. Second is duplication of code. Wherever it was duplication of code, what we can do is we can make a separate class and we can call that function here. Okay, so deduplication of code would also be there. Earlier we were not very much flexible, but now we are flexible. talk about few more optimizations. Okay, so you would be wondering, why do you always want to have a new instance of all the states? Can't we have only one instance of these states? Of course we can have. So let's make all these class as singleton class, so that we need not to make again and again new instances, right? Because we are anyway passing ticket and user, and they'll work accordingly. So we can have them as singleton, which will save a lot of space actually, because there would be not too many objects dangling here and there. So this is one optimization which you can think of. And since we have discussed singleton design pattern in detail in logger class, so I would highly recommend you to do it yourself. I would leave it as an exercise to you to convert this into a singleton design. Now, if you see, let's pick this function. So now let's talk about multi-threading a bit here. Okay. So if you see here, let's say two threads called this function. Okay. Both the threads went inside. They both got is feasible as true. Okay. And they both went inside. Now, if you see, here the state change happens. This is where the state change happens. So don't you think this is a critical section? This is a critical section, right? So what we can do is we can make a lock here. Problem of multi-threading would also resolve here. Two or more threads would not be able to access the critical section at the same instance. I'm doing it for one, and I'll leave it as an exercise for you guys. Okay, so what we can do is we can create a re-enterant lock here. What we can do is we can create a lock around the critical section. So what's the critical section? If you see, this is the critical section, right? So we can start lock.lock, and we should again test if it's still feasible to change the state or not. So if this part needs to be copied, right, then only we need to, yes, okay. And after we have made changes to the critical section, lock dot unlock. So same ways you can do in the above start analysis function and mark done function also. And this will prevent unnecessary setting of ticket state. Okay, so guys, let's test our code. So let's move to the main function. We've already created a user. We have a ticket. So let's ask our ticket service to move this ticket to analysis. So ticket service dot start analysis. Let's send ticket, and of course we can send user u1 only. Since this ticket would already be in analysis, what do you think? What would come as an answer? So let's run this. And yeah, what are you doing? This is what we wanted to come, and it has come. Let's move this ticket to review. So ticket service dot start review, we'll pass in ticket, and of course u1 we can pass. Let's run this, and you can see we are getting the same outputs like we used to get previously. I think you can test it further according to your vision well. So now, finally, what is state design pattern according to whatever we have learned? State design pattern is actually a behavioral design pattern that allows object to alter its behavior when its internal state changes. So we changed its internal state and the behavior changed. So that's what state design pattern used to say. And this pattern is useful when we need to represent different states of an object and handle transition between those states. I hope the definition now makes sense. Okay, let's talk about real life applications. What all real life applications are actually using state design pattern? So if you would have seen traffic light system, right? When lights changes from red to yellow or yellow to green. So on every transition of state of traffic signal, something happens. Basically, car stops when green to red happens. Car starts when red to yellow happens, and they start moving when yellow to green happens. So whenever there is a state change, some different activity is happening. This state design pattern is highly used in game development. Then there are few more places. Audio player, again, play pause state is there. Document editing is there when document is in review or it's in editing phase. So these are all the real life applications. I hope you would have understood what state design pattern is. If you have any questions, you can please post in the discussions panel below. We would be really happy to answer. Okay. Thank you so much.